Mr. James, we're here to do a video going over the concept of properties of exponents. So you can see I have three problems to decide, and we're going to look at all the different ones. We have a product rule, we have quotient rule, we also have our power rule, and we have negative exponents. So we're going to cover everything in this one. So let's just start off with the first one. So I kind of want to look at what's going on. Now in this case, I could right away change and use my negative exponent rule based off of what I see here and what I see here. And I could rewrite that. I got no problem doing that. However, I'm going to try and simplify first. Because if I do the negative exponent rule first, I'm going to create a fraction with this, and I'm going to create a fraction with this. Then I have two fractions. And we know we don't like fractions. So what I'm going to do is I'm going to combine them. And so to combine them, I'm going to realize what I'm doing is I am multiplying my two expressions together. So I'm going to multiply the 4 and the 8 together. And that's going to give me 32. Now when I multiply the x to the 7th and the x to the negative 9th together, what that means is I have 7 x's, x, all being multiplied, and then I'm removing 9 of them. And so really what happens is I'm going to combine them by adding 7 plus negative 9. That's negative 2. And I'm going to write that down. I'm going to combine those by adding. My y is going to be y to the negative 5th and y to the 4th. So again, you're multiplying those. I'm going to combine those by adding the exponents. Negative 5 plus 4 is negative 1. And so that's what I have. So when you are dealing with multiplying like bases, you are going to add the exponents. So I only worked with the x's and the y's with the y's, and that's what gave me the negative 2 and the negative 1 for the powers you see down there. Now what does a negative exponent mean? So that whole thing just turned into one expression now. Well, negative exponent means I have a fraction, so I'm just going to draw a fraction bar. That's what it means. Now we're going to be careful, and I want you to realize what this really says, because this is where some difficulty does happen. This means 32 times x to the negative second. It means x to the negative second times y to the negative first. This exponent is only attached to this base. That negative 2 power is only attached to the x. It's not attached to the 32. And that's a common thing that I've been noticing. So that 32 stays on the top. The x to the negative second becomes an x squared on the bottom, and a y to the negative first becomes a y to the bottom. I don't want write exponents of 1. Why should you do that? And that's really your answer. That's it. Now, you had to be careful because this exponent is only attached to that base. And so that's something to keep in mind. Now, if that negative 2 were attached to both the 32 and the x, then they would have to be in a parentheses. I'd have to see that that negative 2 is attached to both of them, which means I'd have to group those both together. Since they are not grouped together, that means the negative 2 is only attached to the x. So that's the first one. The second one, notice I kind of have the same idea. Now this is your choice. You could either bring in the power rule first, or you can simplify the inside first and then deal with the power rule. I don't care which one. Because we did it the other way on the first part, I'm going to do it this way. Because this one, the way I'm about to do it, by doing the power rule first, is where some people are making some mistakes in the small one. When you bring in this exponent, what that means is you have 3 y to the 4ths. I have a y to the 4th. I'll write it down. I have a y to the 4th, I have a y to the 4th, and I have another y to the 4th. That's what that means. I have 3 of those. So when you bring that in, you're really multiplying. I have a y to the 12th. This means I have 3 x to the negative thirds. X to the negative third, x to the negative third, x to the negative third. I have 3 of those. So that really means I'm multiplying them. That's an x to the negative 9th. Now here's where you have to be careful. This is where terminology is important in math. When I bring this in, it goes to the exponents. It does not come down and magically become a coefficient. That 3 is an exponent, so it's going to stay an exponent. So really that says 5 cubed. And even if I were to kind of cover everything else up like this, I mean, that problem says 5 cubed. So I'm going to have 5 cubed. Well, 5 cubed is 125. X to the negative 9th, negative exponent. That means fraction. So wait a minute. That negative 9 exponent is only attached to the x. Notice that 5 has the 3 as the exponent. So the 125, 5 cubed, goes on the top. X to the negative 9th means x to the 9th on the bottom. That y to the 12th is positive, so it stays on the top. So this one was the power rule. I wanted you to realize when you bring it in, it's like the distributive property, but it gets distributed to the exponents. It does not magically come down and get to that coefficient. It has to go to the exponents. All right, so the last one, really complicated looking, right? I mean, that just looks awful. I have an 18, x, that should not be a negative y, that should be a negative 4. So that would be really complicated if that was a negative y. So x to the negative 4th, y to the negative 3rd, over 12, x to the negative 2nd, y squared, all cubed. Personally, I don't want to cube 18, I don't want to cube 12. It would be fun, but I want to save time. So the more complicated the inside looks, that looks more complicated. What I'm going to do is I'm going to simplify it first. That's going to make my life easier. So I know I'm still going to be dealing with this cubed. I know I'm still going to be dealing with that cube, but I'm going to simplify. And the way you simplify is actually not too bad. I'm going to just visually separate the coefficients, the x's, and the y's. I'm just going to visually separate them. And if I were just to think about, in general, if I have 18 over 12, forget about the whole idea of exponents. If I have 18 over 12, we know what that means. We simplify that fraction. 6 goes into 18 3 times, 6 goes into 12 twice. I simplify my fraction. That's what that means. So that's what I have, by the way. I have a 3 on top and a 2 on the bottom, because I just simplified that fraction. All right, so I'm going to do Mr. Rainsberg's rule on negative exponents and quotient rule combined together. The idea is you take the smaller of them, which negative 4 is smaller than negative 2. And I'm going to move that to the other side, and crossing the fraction bar is like crossing an equal sign for exponents. I have to use the opposite operation. So to move that negative 4 to the other side, I'm going to add 4. And that gives me negative 2 plus 4 on the bottom. That gives me an x squared on the bottom. If I look at this one, I have a y to the negative 3rd and a y squared. Which one's smaller? Well, negative 3 is smaller than positive 2. I'm going to move that to the other side of the fraction bar by doing the opposite operation, which means adding 3. That allows me to get rid of it. And that means on the bottom, I have a y to the 5th. Now, you don't need to do it that way. I just showed a little trick, and if you don't want to, then fine. When you're dividing, you subtract. Negative 4 minus a negative 2, that's the same as addition. That becomes x to the negative 2nd. That means I have an x squared on the bottom. If I have y negative 3 minus 2, that becomes y to the negative 5th, which means I have a y to the 5th on the bottom. Both of them you can see right there. That is all being cubed. So I'm going to do 3 cubed and 2 cubed. So that's 27 over 8. Now we just practiced this. When I bring this in and bring this in, I'm really multiplying to the exponents. Hence why I have 3 cubed, because 1 times 3, and 2 cubed, 1 times 3. If I do 2 times 3, I have x to the 6th. 5 times 3, I have y to the 15th. And that's my answer. Just because it does bother me, I'm going to go ahead and do this to fix it. That looks much better, more symmetrical. And so that's your answer. When you're bringing them in, remember, when you have y to the 5th cubed, that means you have 3 y to the 5th, y to the 5th, y to the 5th, y to the 5th. So that's why we multiply. So this was a quick overview of the properties of exponents. Hopefully you found it helpful.